To kick things off, I'm going to go ahead and share out my screen. We're going to start things off with a bit of a presentation and then dive into the demo. We'll try to leave some time for some Q&A at the end. So like Heather said, be sure to throw any questions you might have into the Q&A widget in Zoom. In the meantime, let's go ahead and kick things off and take a look at what we'll be covering today. We'll start out with just sort of some level setting, kind of what the goals are when we're building something like a Jenkins pipeline in the first place, and what some of the challenges have been historically before we dive into how Chef, and specifically the star of the show today, Chef Habitat, can help us define applications that can be more easily run through our pipelines. So with that, let's start by taking a look at why we build pipelines in the first place and why it's never quite as easy as we think it is at the outset. And it really comes down to, whoop, spoiler alert, what our ideal is that we have a way to automate the release process and ensure one way to get to production for any app that we manage. Now, this, of course, is a simplified view, but really, when we're looking at our CI or CD pipelines, it comes down to building an application artifact and then testing and deploying it across multiple environments until it's finally ready for prod. While this is a lovely ideal, in practice, what we end up finding is that even if we have a centralized solution for a pipeline, we have many different processes that might differ between applications and frameworks, between operating systems, between different teams, and ultimately have different tools managing every different part of each application's lifecycle. And as you sort of multiply out those concerns per app and per team, we end up getting complexity that is nearly impossible to manage. And this is compounded by the fact that, in our experience in the companies we've worked with, folks that are managing, the I&O, the infrastructure processes for these environments tend to be fewer folks than are in development at large. Same thing for release teams. You'll end up having folks that have to deal with a increasingly heterogeneous estate and have to sort of become jacks of all trades and masters of none for all of the different technologies that find their ways into the pipeline. So with that kind of level set, where does Habitat play into this whole process? And what do we mean when Chef talks about modern application automation? Well, a lot of words on this slide. This will likely be for the benefit of folks grabbing things on demand. I'm not going to read all of this, but the important parts are what are in bold up top. The way that we automate things is by providing a unified way to define, package, and deliver applications. We do provide a lot of support for that process, including a artifact repository in Builder that provides us with a place to put those artifacts and inspect them, as well as a dashboard in Chef Automate where we can see the status of our running applications. But the kind of high-level process here is that first we define what makes up our application. We package that application up into a unique artifact called a heart, and then we deliver that to whatever environments need it. And there is a process called the supervisor that helps us facilitate deploying and promoting our artifacts between environments. But where everything starts is in that application definition. And this is sort of a core tenet of what makes an artifact unique when we're talking about a Habitat artifact. Is traditionally, when I've worked primarily in operations roles, when I think of an artifact, I think of compiled application code. And that is certainly part of what gets built into a heart, but is only part. We also are defining things like what are the instructions for building that application? What configuration parameters are going to need to be defined? What relationship is our application component going to have with other components? Do I need to talk to a database backend, cache, other apps in a microservice architecture? What dependencies does my application have, both for its build and for its runtime environment? And then, of course, what are the actual things I need to do for my running application? How do I restart it? How do I check its health? All of those concerns are built into an application manifest that provides a single way to define every aspect of our application's lifecycle, from its build process all the way to its running lifecycle. So when we take a look back at sort of what challenges we've had in sort of creating pipelines, again, what we're trying to strive for here is a uniform way to promote our applications. But if we want to take a very more specific look at where some of the challenges lie, well, let's put a finer point on that. How do we build our app in the first place? If we take the example of a few different frameworks here, if I've got a Java app, a Python app, and a .NET app, I actually have different tools that are used to build those apps, Maven or .NET, etc. And these challenges end up getting compounded the more tasks we have to perform. Not only are these applications likely to have unique build processes per application, but what it means to actually deploy that application might be different from one app to another. And even this might be manageable if every team, say, deployed an application the same way, but we end up getting these things further complicated by the fact that, well, I might actually have a different process in development than I have in production. What's happening in my pipeline might be different than what's happening in sort of my initial build tests. And ultimately, when you take sort of this core problem and multiply it out from all the different jobs that need to happen in any application deployment, it's no wonder that there's not an easy way to get that uniformity with our traditional practices. So ultimately, what we end up having is not one way to get to production, but one way for each app permutation that we have. We have sort of an example here. Well, while each of my apps needs to be built, I might have different ways to build all of those apps, to say nothing of things like pre-built apps or COTS, off-the-shelf applications, where I don't control the build process at all. And if we take that and we take a look at all of the other tasks we need to perform, that's where the reality becomes, well, different applications use different methodologies, even if the tasks we are performing are fundamentally the same. So how does Chef Habitat help us solve this problem? And this is where the rubber meets the road for that application manifest we talked about earlier. So if we take a look at a specific example, say a Java app, spoiler alert, we will be seeing a Java app in the demonstration that is built and deployed in roughly the fashion described here. Historically, all of my app-specific concerns live in the pipeline. So I'll first need to know what tools I need to build my app, and I'll need to make sure those tools exist on whatever sort of build nodes or job executors I'm running. And then I run that process. In this case, we're installing and running Maven to build a Java artifact. Then when it comes time to deploy our application, well, we'll need all of the runtime things I require. Might be using Tomcat to serve out the app. I use Mongo tools to make sure I can communicate with the database. And then ultimately might have something like a WAR file that gets copied to a directory and run with Catalina. What's important to know about Habitat is that none of these steps are any different in my habitized Java app. I'm still building it with Maven. I'm still serving it with Tomcat. What's different is I'm not defining those things in my pipeline, but instead in that manifest that Habitat builds for us. So when it comes to where do I define that I need Corretto and Maven, I define it in what's called a plan. I also have a number of definable lifecycle hooks so that when it comes to how does Maven package work, we have a hook for that. How does the process of copying out our WAR file and running Catalina work? Well, we have a hook for that. And all of these are sort of predefined. We have a library of different hooks, like the run hook you see here or the build hook. And those are written in just platform native shell. So we don't have a domain specific language or any sort of new syntax for it outside of providing some sort of helper templating and parameterization. So things like determining what the path is for my package or where my cache exists isn't something I need to explicitly define. We have helper functions for that. But ultimately, since I'm going to be running this on Linux, this is just bash. So it's kind of interesting where sort of things are the same and different. I'm still taking the same steps to build my app, but making it part of the repository that hosts my source code as well. So why do things this way? What it lets me do is actually create a pipeline with a much narrower scope of what needs to be done. Since I've created that manifest for my Java app, my build and deploy is just hab package build, hab service load, some habitat specific functions. And this becomes particularly transformative when we compound it out onto an environment that has multiple different frameworks in use. If I go ahead and build a Microsoft.NET app, guess what? I'm still running hab package build to build. I'm still running hab service load to deploy it. In these cases, the specifics of what makes an app a Java app or a .NET app, Node, Ruby, what have you, live inside that manifest so that I don't need to have a per framework, a per OS accounting in the pipeline itself. This has multiple benefits, including that it takes away the problem of, say, different teams using different processes. The process that's used in the beginning of development is the same process that's used in production. There might be different configuration tunables or different system resources available, but fundamentally, the way I build and run these apps are uniform for each app, and the way that I trigger those tasks are uniform across my apps. So that ultimately, we can go ahead and dive into what that looks like functionally. So I'm going to take a quick look and see if there are any questions before I dive into the demo. Feel free to go ahead and throw those in, but then I'll go ahead and do a bit of a larger screen share so we can start seeing some of this functionality in action. So I do have a bunch of infrastructure spun up, as well as a few applications that are running here. Two primarily. One is called Sample Node app, which, as the name implies, is a Node.js app. I also have an application called National Parks, and if you've joined a webinar that I've run before, you may have seen the National Parks app. But it's not the app itself we're going to be focusing on today, but how work is done on that app. And to that end, I have two pipelines created in Jenkins. Now, in Jenkins here, the only sort of plugins that I have installed are Blue Ocean, so I have the nice GUI here, as well as a Habitat Executor plugin that provides a nice and easy way to run some of those app-specific commands. But I have 0 plugins that are specific to Java or Node, because that's actually built into the applications themselves. A good place to start is going to be with my sample Node app here, where thankfully for us, we actually have the version, the human written version that I've created, as well as a unique build number that happens every time we build this application. So to do a deploy, I don't even need to push any new code. I'm going to go ahead and trigger a new build. And because that's part of it, we'll actually be able to see it in the output that we'll see in the page here. This is my dev environment. And then we'll have a prod environment that we go to later. But ultimately, what's happening in my pipeline here? Well, first, we're going to go ahead and build our artifact. That build process is controlled by Habitat. So you actually see this hab studio build command that gets run on my worker. And indeed, that's going to go ahead and grab the dependencies I've defined. And ultimately, well, it's going to go run Maven. So after it's installed all that stuff, it's going to do a Maven build and actually, or not Maven, this is Node. It's going to go do a Node build, forgetting which app I'm working on here. But actually a good place to call out, if we go into Builder here, which is the artifact repository for my Habitat apps, I can see exactly how my sample Node app is being managed here. And in this case, I've actually got a fairly straightforward and simple plan, because we have scaffolding for Node.js. So I actually don't need to necessarily know what the build process here is. I'm using the default framework process that's defined in our scaffolding. And only if I need to do something that isn't covered in that scaffolding do I need to define something specific. Here, for example, I have a special dependency that'll come in later that I'm using. and I'm defining things like what port my application runs on, so that I have the ability to change some configurable content. But for the most part, the scaffolding is going to be doing the work for me. We'll contrast that with an application we'll be seeing a little bit later called National Parks, where I'm actually very much explicitly defining what is a build. I'm going to go grab my source code and run Maven package. What is an install? I'm going to go ahead and copy the content I need to a defined directory. And still, I'm defining all of the configurable parameters that I want to be able to manage in my environment. Back in our Node app, what ends up happening is we go ahead and built our artifact. It's uploaded it to Builder, so I should actually be able to go into Builder here and see that there is a new version of my sample Node app available. And indeed, this latest version here has been promoted to a channel called Dev. More on channels in a second, but it's not in stable. What that ends up meaning is if I go to my dev environment here, where previously I had this 5244 build running, I should be able to refresh. I have a new build, 71544. Compared to production, where I still have that old 244 build because I've only promoted it to the channel. So this is where channels come into play. Inside of Builder, we have the ability to promote artifacts through user-defined channels. And those channels can in turn define where they get deployed. All of my environments today are deployed with what's called an at-once strategy. As soon as there is a new artifact in their respective channel, they will run through whatever deploy processes are defined in that manifest. Since I've gone and promoted to the dev channel in my pipeline, we can sort of see have package promote. That's all that's happening in the background. And I've waited for dev to deploy. So there's actually an API here that I am using to compare what's currently running in my dev environment versus what is the latest version in the associated channel. And it'll just wait until those numbers are the same. And then I know my deploy is complete. And then because I'm able to define what the health check is for my application within the app itself, it goes ahead and checks that API endpoint to make sure the app is healthy. This is actually something near and dear to my heart. Back in my previous life as a operations person, I worked at a few managed service providers where my customers had all different kinds of applications, and I was in charge of making Nagios alerts for all of them. So I had to become a little bit of an expert in each of my customers' applications because I needed to know how to tell whether that application was healthy or not. Because with Habitat, we are defining what health is in that manifest, all I do for all of my apps is I hit an API endpoint. And the API endpoint just says, yes, no, am I healthy? And that means I can go ahead and move on to the fun part, which is, am I ready to deploy, in this case, to a canary channel? Because my production environment is set up with a canary deploy. I have 3 nodes sitting in production, and I'll first deploy to a canary, which will kick off now. All that does is promote to a new channel and wait for a deploy. Exactly the same process we used in dev. Once it's done, since I have 3 nodes, one of those 3 nodes should be on the new version, and 2 of them will be on the old version. We'll then promote to a 50% channel, which in this case will deploy to 2 of 3, and to finally my final stable channel, where all of my prod environments will see the deploy. The nice thing is I'm doing a round robin here, so it'll be very easy for us to tell whether or not I was successful in that deploy. That said, if we go ahead and take a look at the actual Jenkins file in use here, it's pretty much the exact same steps for each of these environments. We start with, and this is the credentials we're using to authenticate to my depot, since it is all sort of key authentication based. I go ahead, build my artifact. I go ahead and upload that artifact. And then all the rest of my tasks are a promote to an associated channel and a couple of shell scripts that we can, if folks are interested, look at later to determine what the deployment status is, what the health status is, and then move on to the next step. And the next step, exactly the same. Promote to channel, check that health. The same script, nothing different, just different environments that are being evaluated at each turn. Once we get, that's my slide deck. Once we get back in here, I can see, all right, looks like my pipeline thinks canary is healthy. What happens if we look at production? Instead of that 244 everywhere, I should see it 2 out of 3 times. So there's 71544. 1, 2, 3, back to 1. So we can see in kind of the round robin here that 1 out of 3 nodes is running on that latest version of my code base, whereas the other 2 are still waiting to see a deploy. And that's going to be triggered the exact same way. So that's all well and good, but honestly, you know, that's not altogether different from what my process might look like for a single application. I'd be doing some node-specific stuff instead of some hab-specific stuff. But whenever we're talking about automating things, really the transformative thing is not how it affects one thing, but how it affects multiple things working together. So let's hop back up and take a look at national parks. So national parks is different in a few ways. One, it is a Java app. And 2, I'm actually doing some blue-green deploys instead of a canary deploy. So there's a little bit different functionality in this pipeline. However, the mechanism for me triggering changes is exactly the same. So national parks is going to be a little different. I'm going to actually make a code change here. Stop me if you've heard this one. We're going to take these blue pins. We're going to make them red and do some other style updates. Thankfully, I've got that all sitting and ready in my repo for me to just copy the associated index into my source directory over the existing index. I'm going to go ahead and commit that change. And because I love doing this in demos, I get to do the thing that you should never do, which is git push origin master, because I don't have a prod and am in full-on YOLO mode. So I push this change to master, and I'm going to go ahead and trigger a new build in my pipeline if Zoom doesn't want to cover up my tabs so I can get back to it. Oh, I'm not even in the right window. So I go in here, we'll go ahead and trigger a new build, and we'll go ahead and see how that build happens. So here we'll go ahead and check out the change from Git and start a new build and see how this all goes. While that's happening, we can take a look and compare my sample node app Jenkins file to my national parks Jenkins file. And again, almost identical here for the first few steps of the run. I'm still just running that build task with the Habitat plugin. I'm still running the upload task, and I'm still just promoting to a dev channel and then some later channels. The only big difference here is that while in my canary deploys, I am deploying to a live environment, in my blue-green deploys, I'm actually going to be removing some of my machines from a load balancing pool to test a deploy first and then re-add them back. How does that get accomplished? Well, in this case, via that same API. So because I have the ability to define configuration tunables, in this case, I am defining a tunable for deployment mode, because my load balancer, in this case, HA proxy, is also deployed with Habitat. It's going and watching all of its pool members. And if any of its pool members start having that deployment flag set to true, it's going to go ahead and pull them out of the pool for us. So in contrast to our canary deploy, when I go ahead and say dev looks healthy and I'm ready to promote to prod, it's going to remove my blue machines from the pool, deploy to them, and then I'll be able to go ahead and look at the blue environment directly to see if the deployment happened. But my live environment is still going to run in the old version of our app 100% until I go ahead and trigger the flop. Do the same thing for green, put blue back in the pool, take green out, deploy to green, and then ultimately put everything back in the pool. So we'll be able to watch and track that as the deployment happens. But in the meantime, we see sort of the same process happened. We went and we promoted to the dev channel. It's going and deploying to dev. Did my change happen? Why, yes, it did. Development's now got the red pins. My pipeline says that it's healthy. So all I have to do at that point is trigger the promote to production. At which point, we can see that right now, there are 6 nodes sitting in my production load balancer. When it pulls blue out of the pool here, I should end up seeing an HA proxy. Boom, half of those machines are gone. When we go to that HA proxy box, this should never change from blue to red until I move on to the next step. but the actual blue environment, here I'm going directly to one of the nodes in that blue environment, will see those red pins as soon as the deploy completes. The process here, well, it's exactly the same as the process was for my Node app. Again, this is where we start seeing that I do not have a per framework accounting for how this stuff works. I'm using the same APIs, and in this case, the exact same deployment status script. I'm just providing it different arguments. This time it's looking at a different application. Whoops. It's going to go ahead and run it for the National Parks app, but it's the exact same script that is now sort of waiting for me to see, did the deploy complete successfully? It looks like it did. Does my live load balancer still just show the blue app, no matter how many times I refresh it? Sure does. And, you know, I'm realizing I made the same mistake here I did the very first time I did this, which is that I have labeled my environment blue and my pins are blue. So this is actually the green environment displaying the blue version of my app. But you get the idea, I hope. And if not, I'll find out in the Q&A widget in a second. But blue does look healthy to me, so I can go ahead and take this the rest of the way, where it's going to go ahead and do the same thing in reverse. In this case, we'll see these 3 machines get replaced with all of my machines now that they're all getting thrown back into the pool, and a new deploy is going to happen on the other side. So it's adding blue back in the pool. Now it's taking green out to do the deploy there. My production load balancer shows the new version of my app now. And once it finishes doing the deploy to green, we could do the same thing. I'm honestly going to just take it as a given now in my abbreviated workflow for the webinar, and we can go ahead and bring everything back into the pool. So at a high level here, we have sort of a way to fundamentally track things across different applications. And back in Chef Automate, we can even get some sanity checks on what is actually running where. So if we take a look at sort of prod green and prod blue here, we can see the versions of each that are running. These get updated as we do deploys. So we'll be doing another deploy in a sec, and we'll see sort of that we can confirm the difference between these things. You'll also see some things that aren't my applications. So I'm also doing some security auditing and some infrastructure hardening here. And those show up on the applications tabs. The reason that those show up in the applications tab, we can actually see the details in my infrastructure and compliance tab. But even though I'm using Chef Infra and Chef Inspect to perform those tasks, those are applications. And those are applications that I can bundle up with Chef Habitat. So if you've heard of the effortless pattern before, it's essentially me taking those tools that I use to enforce my audit policies and my configuration policies and treating them just like any other application. I can create a pipeline, and that artifact in this case is not just the Chef Infra and Inspect executables, but the policy for those executables to run, all in a single artifact. Just the same way that my application artifacts for Java and Node.js are my compiled source code, as well as everything that's needed for its life cycle. So we end up having a uniform way to treat sort of the applications we develop in-house, the middleware that we use to run those applications, the sort of DevOps tooling that we're using to automate all of the lifecycle management, all managed in a single uniform way. And once my pipeline is done promoting things to green, I can go ahead and take that last step, promote things to stable, put everything back in the pool, and I should ultimately see all 6 of my machines show up in the load balancer once again, and all 6 of those machines should be running the latest version of my application. Now, this ends up sort of compounding the things that we can do when we're evaluating our applications, and in particular, when we're taking a look at problems at any point in this life cycle. So I had mentioned I had added a extra dependency to my applications in the form of this thing called lib-hello-world. This is a little arbitrary library I created. Calling it a library is being very kind. It's literally deploys a text file that says hello world. But what happens if I go and demote the current version that I have in stable and go back to the previous stable version I was using before? And I try to trigger a new build of National Parks and of Sample Node app. What ends up happening is each time I build, it's going to build a unique version of this app. And even though the application itself hasn't changed, something in its dependency chain has. And this can sometimes be the most frustrating way that an application can break. Oh, sample node app, I never finished that other deploy. But part of the reason that it can be frustrating is that it can be very hard to tell whether a failure is due to a change that I just made or due to something upstream that changed since the last time I deployed my application. If we're doing things in sort of the traditional way, right, and we're making sure we just install components on our tools nodes, that can be very hard to keep track of. If every time I hit a new worker, that worker might have a different version of Maven, say, if I'm not pinning things. And I can find a lot of inconsistent behavior as to whether or not things build successfully or failing. The absolute worst experience I have ever had maintaining things is if I just rerun it and it magically works and I don't know why. And oftentimes that'll be the reason. Something way down in my dependency chain was a little bit different on server B than it was on server A. And so not only am I defining all of the tasks that need to be run throughout an application's lifecycle, I'm defining explicitly what dependencies it has, and each of those dependencies is in turn a Habitat application. So all of those dependencies, and we can kind of see my transitive dependencies down here all the way down to Linux headers and glibc, I can see exactly what version they are, what build they are, and what configuration options were used to build those things all the way down the chain. So that in the case that I have an issue, and I suspect I'm about to have one here, and I do, I have some tools that I can use to evaluate what that issue was. This time we did our deploy to dev, and we haven't changed our application, but the health check returned false. In this case, because I can use those same APIs that I use to determine health to see what that full transitive dependency chain is, I'm actually comparing everything in my running app to what is currently sitting in the stable production channel. And I'm seeing, okay, all of these dependencies match, but oh, in production and stable, you're using this version of libhelloworld, and the build you just created, you're using this different version of libhelloworld. So now I have a specific reference to where my problem may lie, at least something that is different between the current build and what's running in prod. And I have the ability to very early in the pipeline process, evaluate the nature of that failure. I could, in this case, just do an explicit version pinning. Maybe I want to definitely make sure we're using this version of libhelloworld. And in fact, if you take a look at my National Parks app, I am doing that for, I believe it's Corretto. Yeah, so in the case of Corretto, I'm pinning to a specific version, whereas in the case of libhelloworld, I'm just using no pinning, which will use latest stable. Alternatively, and what I'm going to do here is I can just go ahead and say, oh, you know what? That demotion I just did probably wasn't a thing that I want to do. Let's go ahead and fix that and promote the version that I know worked before back to stable and rerun that build. And if that was indeed the problem, simply by rerunning the build here, I should be able to determine whether or not I've solved my problem. So we'll kick off a new build. It's going to build everything, including the dep chain. It should now pick up that there is a different version of that upstream library in the stable channel of my artifact repository. And if we're right, and that's where the break was, the dev health check should return clean once again. And spoiler alert, that's what's going to happen. You can see here that this was me testing it out this morning to make sure everything works. And here's me rerunning a build after changing the dependency. So we end up getting not only that good level of information that's all done via sort of uniform API checks, but that audit trail where I can see not only what changed in my application, but what changed across the entire dependency hierarchy, all with what ends up being a very uniform set of steps. Now, the same thing holds true. I have here a Windows app that I've done sort of similar things to in the past. The only difference here is I would give it a label in Jenkins so that it's using my Windows workers instead of my Linux workers. But ultimately, same process. I build, and if I need things to go into a specific directory or something for my environment, we can throw some PowerShell in here. But sort of the upload and promote tasks, exactly the same as what we were doing for our Node and Jenkins, Node and Java apps, respectively. So what that ultimately brings us to is that we have sort of a way to get that uniform behavior across even a very heterogeneous estate. For what it's worth, the plugin that I'm using here is available in Jenkins plugins. It's a Habitat executor. And really what this does, it provides some nice Jenkins-y syntax for these things. But even without a plugin, as long as you have the Habitat executable available to you on wherever you're doing your build and deploy jobs, you have the ability to do exactly what I'm doing here. Again, what this ends up providing you is a consistent way to work with a wide variety of applications, because all of the things specific to that application live in version control and not in the pipeline itself. This allows us to get huge gains in how quickly we can iterate. And some actual data from one of our customers, we have a nice before and after picture where they would create sort of what the build process is for a new product or feature. They would have run books that needed to get updated. They would have sort of capacity provisioning and configuring. And ultimately, that would sort of be split between automated and manual processes. And what it ended up meaning was, even after they had created a new app, product, or feature, each iteration of it had extra work that would end up being ultimately 5 months soup to nuts to get a new thing out the door. And everything after that initial build is still happening a lot of the times on subsequent releases. Now, again, in the after picture, they're still spending some time up front creating those codified plans. And that's going to be very similar to whatever they were doing previously. It's, again, in my apps, it's still Maven doing things under the hood. I'm not doing anything fundamentally different to build that app, but I'm putting that into this manifest so that I don't then need to redo or account for extra components later on. So ultimately what happens here is, once that new feature is built, everything else is lightning quick. We can iterate on this, add new features and things without having to worry about, does the new capacity I've spun up have the prerequisites for my app? My app defines its prerequisites right in that artifact and is building them the same way every time. Is the build infrastructure going to need to change? No. Again, my app is bringing with it what it needs to build. I don't even care whether or not my build or runtime environments have completely different version of core things like glibc, because my artifact itself is defining a very specific version of those things every time it gets built. So ultimately, a lot of the problems that we see over the application's lifecycle that can come out to differences between environments become a non-issue, because there's only one way to build every specific application. And once you have that artifact, there's only one way to run it. And where I deploy it, or even what technology I use to deploy it, I can export these things into containers. There's some native sort of like, Docker export functionality in Habitat. And again, it's exactly the same depth chain as if I go run it in traditional bare metal systems. And ultimately what that gets us is we can go back to what our ideal was: a single way to build, test, and deploy our applications, and make that a reality. Because now, even though I might have different pipelines for each of my applications, what happens in each of those stages is going to be exactly the same. I run hab package build. What does hab package build mean? Well, it's the same for every single one of my applications. And with that, I'm going to go ahead and stop the screen share real quick and take a look at some of the questions that we've got out in the wild there. Let's take a look at, here's a low-hanging fruit. How do we do rollback to previous versions? There's a few ways to do this. Typically, what I will end up doing is a roll forward. So kind of what you saw in my error example, rather than rolling back to an earlier version of my national parks build, I trigger a new build with sort of a reversion in the thing that I'm rolling back. That would be true if I was changing things to the source code. I might do a new commit that undoes something. And typically that tends to be my preference from a auditability perspective, because now I have sort of my rollback triggered as a new build. That said, that's not always going to be feasible, and we actually have some rollback functionality being worked into this. And I think, have we done that webinar already, or is that?
We have a blog and a demo posted that I put the link into the chat for folks that want to take a look at that. But rollback launched in Hab 1.6.
Gotcha. All right, cool.
And there's more information on that for folks that want to take a look at it. And if somebody wants a demo or more, you can email me at that same email address in the chat.
Yeah, no, thank you. And interestingly enough, there is another related question that someone apparently is familiar with that feature since it was recently integrated into Habitat. And indeed, how would that get coded into a pipeline? I actually need to familiarize myself with it a little bit better, but I suspect I would just create a new task that triggers the rollback, and would either, depending on how I want my pipeline to work, I could say if we run into that health check error that we ran into, I could have it automatically roll back. One of the advantages to being able to fail fast in dev is that in this case, I actually am fine not rolling it back because the problem hasn't made its way into a sensitive environment. And by keeping it there, I can do more investigation if need be. So I think ultimately it would probably just end up being a new task in the pipeline, and whether it's automatically triggered or triggered by a human will be up to sort of the pipeline designer to decide. There is a question here asking about sort of what the difference is between Chef and Ansible. And this is actually something where it's a little bit easier to put a finer point on it, because primarily what Ansible concerns itself with is the infrastructure side of the equation. So Ansible is probably best compared to Chef Infra, where both are configuration management tools with a slightly different philosophy, where Ansible tends to be more push-based, whereas Chef tends to be more pull-based. The difference being that whether you are initiating a change from outside in or inside out, like my systems here are even doing the app deploys in a very pull-based manner, where they are polling a source of truth, and when that source of truth changes, they update. And that's actually one of the things that I like about Chef Habitat, and particularly running a tool like Chef Infra within Chef Habitat, is it almost makes the traditional pull versus push conversation to a certain extent obsolete. Because I still have Chef Infra set up to poll on a regular interval. I can say, run my policy every hour and make sure that my systems are up to date. But I can also build a new version of my policy, run it through my pipeline, and as my environment sees that there's a new version of my policy, it doesn't wait for that hour. It runs automatically. So I kind of get as much push as I need while still having a baseline pull methodology. And really, they're both pulls. It's just I'm checking that source of truth at a more frequent interval for changes. So it doesn't have what, in my mind, is the primary drawback to a push-based model, which is that you have to, A, open up incoming traffic to the things that you want to manage, and B, you need some sort of centralized orchestrator to push out those workloads. In this case, we're still just watching that source of truth in the artifact repository and determining whether we need to short circuit our usual polling interval. As far as some of the other tools in Chef's toolkit, like Chef Inspec and Chef Habitat, there isn't really an analog in Ansible. There is definitely a sort of a methodology for using an infrastructure-based tool to do application deployment. It's actually something Chef Infra did before we had Chef Habitat. And whether kind of, a tool like Infra or a tool like Habitat is the right tool for the job is going to depend a lot in your environment. I'd say sort of as a best practice for something that's fully greenfield or hasn't been automated at all yet, I would tend to favor Habitat just by virtue of kind of all of the gains we get that were shown off today. So let's see here. I showed compliance testing with inspect reporting back to automate. If I wanted to put it into pipelines so that it would fail compliance and doesn't even make it to dev, could we do that? And I would say at a high level, yes. And in that case, what we would end up having happen is we can trigger inspect in much the same way. Again, dovetails nicely into sort of that Chef Infra conversation where I'm bundling inspect in the same way so that when I have an update to my policy, I can have that trigger a run. There is also an inspect executable that I can use to do ad hoc scans. So I could either have my pipeline directly run inspect against the target environment. And if I don't want to, do all the port opening as mentioned before that I would need to do that, I can just sort of have it automatically happen via my running package. And Chef Automate has an API similar to the way that Habitat has an API. So I could go ahead and query Chef Automate for the audit status of my systems to see whether or not there's an audit failure before triggering a promote. How do you handle dependencies on other applications that may be on different servers as part of the deployment pipeline? And for that, I'm actually going to share my screen again because when we talk about dependencies, there's a couple of different kinds of dependencies that we can be talking about here. So if we take a look at, and I'll take national parks as a good example that we can run down here. There's the dependencies that we see here in my build and run dependencies. This is actually what the dependencies are for that single instance of my app that I'm running. So I'm actually running Tomcat on the same, VM in this case that I'm running where my WAR file is located. But I am running something like Mongo externally. There's a separate Mongo server that gets connected to. So if we take a look at the plan, and this is something that exists in every Habitat application, we have some exports and some binds. The exports are the things that I need to make available to other services. So in this case, because we're sitting behind an HA proxy load balancer, and I'll make this a little bit bigger, I want to make sure that HA proxy knows what port my application is running on so that I can configure its backend accordingly. And because I'm doing blue-green deploys here, that deployment variable that I'm exporting is just a Boolean that I can change from false to true if I want HA proxy to pull things out of the pool. By a similar regard, my binds are what things my service is going to be externally speaking to. In this case, I need to know what database and port I'm connecting to. My database, the front end of Mongo, is a Habitat package in this case as well. So again, it's just going to go ahead and figure out in that service ring that it runs in, who in my group is the database and what port is it running on. And the nice thing there is that it opens the door for even more complex deployment scenarios. So if we go real deep into how Habitat works, we can set up topologies. And I've deployed this with a single database backend or a clustered database backend. The bind is the same in either way, and I actually have Habitat triggering things like leader elections. So when I bind to that database, I can give it my whole pool, and Habitat will just tell it which one the leader is. If that leader gets demoted and there's a new election run, without my having to take any explicit action, it's just going to go ahead and detect that there is a new leader and update its database connection string accordingly, which is exactly how in our case, HA proxy was adding and removing things from its pool. In this case, I have a few different backends to handle my blue-green deploy. And I am going to go ahead and do I have this? I might actually have to go to the source code for that. But in my hook, I'm going and I've just made a conditional statement in my template for HA proxy. And actually, let's have some real fun and go into my Chef Rykar Git account and take a look at HA proxy and hope that I'm remembering. It helps if I actually give it the full URL. And what's actually happening here, if we look at my config, is I actually have a templated haproxy.conf that for each of my backend, as long as it has a backend member that is alive, and in this case, is it passing its health check and is it up, it's going to go ahead and unless, again, another template conditional here, unless that member has its deployment flag set to true, it's going to add a line to the config file with that member's IP address and config port, which IP address is a sort of an internal of the package. I don't need to define that. It just is something that can always be queried. And then the port is what I defined in my exports there. So what actually happened here when I did that deployment is HA proxy, which is constantly taking a look at all of the members in its group inside the supervisor, said, all right, well, this deployment thing changed, so I need to rewrite my config file because anything in the additional case, the blue group, now has deployment set to true, so I need to remove these lines. Very similar to how Chef Infra works to define desired state. Once it does that and sees now that only the members that have deployment set to false are in the pool, it'll go ahead and run through its restart hook, and now I've got my updated pool members. So you end up having a lot of very complex inter-service interactions that can be configured in a very straightforward way. It all just comes down to a combination of exports for the things that you want to tell other services about. So sometimes I've done systems where I've put HA proxy behind HA proxy, so I have it have similar aspects to my web front end, and binds, which define what things it's expecting to be able to interact with. Additionally, I can make binds optional. In my Node.js environment, I'm not doing a blue-green deploy, so I don't care that there are no blue or green backends defined. But in the case of national parks, I need a database. So in national parks, my bind is not optional. If I don't find a database when I'm querying the supervisor, I can't start. So there's a lot of flexibility within the core framework of Habitat that ultimately makes it very easy to define complex behaviors. As far as the deployments themselves, since I'm in the neighborhood, quick look at, I mentioned I'd give you a peek, and I can definitely make this available to folks if folks are interested. The scripts that are checking my deployment status and checking my health are really just making API calls. Here, for deployment status, I'm querying builder, which is my artifact repository for what the version is in the specified channel. Whereas for my running version, I'm instead querying what's called a peer. This is essentially a long-lived member of my supervisor group whose job is just to be a endpoint that I can point DNS at. And even if all of my members are ephemeral and come up and down, this peer is something I can query for status about any of the other members. So here I'm looking at the census data that's collected. I'm looking through that for the release number, and I'm waiting for that release number to match the release ident in my artifact repository. When it comes to, I actually launched these with Terraform, how the environments are actually set up. Really here, for each sort of discrete deployment pool, I have machines that are watching a different channel. So I have a set of, it's HA proxy. Let's look at my actual nodes. So if I go into here, say my green environment, well, the count, by the way, is my total count divided by 2, because I'm just splitting it in half here. So it is dynamic. I could add 20 machines and I wouldn't have to change any of my Terraform. 10 would be in blue, 10 would be in green. And for each of those, I'm going to go ahead and take a look at the, in this case, okay, audit national parks. National parks is going to be in its own green group and watching its own green channel. But I have sort of what my update strategy is, and here's where that bind is set up. So I'm going to ask it to bind anything that's called MongoDB in the same running group as national parks itself. So you end up having that flexibility where for my sample node app, the only difference was here I was doing canary deploy. So instead of 2 machines with half of our nodes, we have, or 2 groups with half of our nodes, we have 3 groups. Where if we first would have, if we take a look, I should just collapse these. Yeah, that's a smarter way to do it. I can go ahead and take a look at first my canary, which just has a set count of 1. There's only ever 1 canary in my canary deploy. Then my first 50% are whatever my count is. Oh, in this case, I I just made my 50% a 1 as well, since I just did a straight up, I didn't actually make this scalable the same way I did my blue-green. Otherwise, it would have been count divided by 2 minus 1 for the canary.
Hey, Nick, I have a couple people saying they're seeing a blank screen.
Oh, dear.
Sure why?
That's no fun. Is that, I've stopped my screen share now and let's see, I'll start it back up. But I can go ahead and make sure I post the code examples that I was talking through there. The long and the short of it is that the Terraform itself is only accounting for however many different places I need to deploy to, which is dictated by my deployment strategy. So I'm either deploying to half and half for blue-green, or to 1, half minus 1, and then half again for my canary. But ultimately, you end up having sort of the same thing true across the board. And the nice thing is that, like, I am by no stretch of the imagination an app developer. I cut my teeth in operations. And so being able to package things up this way gives me the ability to manage a lot of different things without having to go learn a lot of specifics. That includes Jenkins. I actually didn't end up managing Jenkins much in my ops days, but guess what? I've got Jenkins as a Habitat package. So I've gone ahead and defined what plugins I want to install, what credentials I want defined as part of that Jenkins Hab package. And that actually kind of, I saw a question about sort of how things like COTS applications would be managed, since in a lot of the cases where you have off-the-shelf apps, you don't have access to the source code and build process. So does Habitat still have a role to play? And the answer is yes. The only hard requirement of being able to habitize an application is that it has a silent installer. So if there's a GUI install, I can't do that very well. But as long as there's a silent installer, basically the only difference between a COTS app and a homegrown app is that Habitat's not controlling the build process. I'd have the equivalent in, say, my Jenkins environment. I'm not building from source. I'm actually grabbing the WAR file that Jenkins produces, and I'm just skipping the build step and saying, I'm going to grab the pre-built application that Jenkins provided to me, and I'm only going to worry about my runtime configuration. So there's a lot of flexibility within that we've used to manage a lot of COTS. Like we've done a lot of, I think, like SAP HANA work with customers as well, and things where they wouldn't necessarily be able to count on access to source code. And since we've got about a minute left, there's a question near and dear to my heart here, which is sort of in-place deployment versus ephemeral builds. So in the example here, let's say I have a hardened AMI, and then I use Chef to do the config management. And whenever there's a change, I just replace the whole VM versus doing in-place deployments. What are sort of the subtleties of using Habitat in that kind of environment? And that's exactly the sort of consideration that we'd almost want to make the default. Now, whether you update in place or redeploy ends up being a decision that you would make based on sort of the tools you have at hand. Like if you've got sort of, cloud-based infra and it can be pretty disposable, you can kind of make that call. But the nice thing here is that we can actually have Chef Infra's only purview OS hardening, and everything that goes on top of that OS is managed in Habitat. So that I really only need that one hardened AMI, or at least one per deployment environment. I might need Linux and Windows or different flavors of Linux. And since that Habitat package brings everything else it needs with it, I can just harden everything I need to on the OS. And I don't even need to worry about installing things like Maven directly on the OS, where I might, have it in a prod node where I don't need it. And then there's, a vulnerability for a build piece that I didn't even need in my prod. Well, no, I only have the things that my app needs. And then 100% of what Chef Infra does can be hardening. So I think it's very flexible in that environment. When it comes to auto scaling, kind of the same deal. When I bring up that machine, I just do a Hab service load. I pick the right channel. And when that machine comes up, it will just pull whatever the latest version of my app is for that environment. So it can be very flexible, both to long-lived persistent environments and very ephemeral disposable environments alike. And with that, looks like we are at the top of the hour. So if I did not get to your question, do not fret. I will go ahead and see if I can't cover those when we do a wrap up and provide the on-demand webinar. But I'd like to thank everyone for joining us today. And is there any closing housekeeping we need to do, Heather?
I think that's it. I just want to again thank everyone for their time. Hope they found the event valuable, and to look for an email for the recording. I know a number of folks have asked about that. And if you have any other questions, feel free to email me directly at hpayton@chef.io. And hope everyone has a great day then. Thank you.